Hey guys, this is video 6.4, naming binary ionic compounds. So in the last video we talked about monatomic ions, so just single ions of one element. But now if you take a look, right, that term binary, how many ions do you think we're going to have? We're going to have two. Okay, so this is two ions in a compound. Okay, so again, you should be looking at this video and then 6.5 as well before you do any of this practice over here and before you do the dice lab. And remember, save the dice lab until after you do these three worksheets and that you get them practiced. So really, if you keep following the pacing guide, you should be watching all three note videos in the first couple of days and then try to start working on the practice after you've gone through and make sure you've gotten every single type. And remember, do not start any of this stuff down here until after you've completed all of this in here. Okay, because if you start throwing it in there, I promise you'll get confused and then things will start going haywire and you'll try to start using that. So let's jump right in. We'll be on page 7 in your packets. All right. So let's kind of talk about the rules first, then we'll do some practice together, and then you guys will try on your own, and I'll come back and kind of go through the key so you guys can check your work, and I'll kind of explain pieces that maybe you got wrong. So when we talk about forming binary ionic compounds, the total positive charge must equal the total negative charge. And we've already seen this in Unit 5 with bonding, right? You guys were given something like silver plus oxygen, and you had to figure out, well, how did they bond, right? So if I just gave you silver plus oxygen, you'd have to figure out how do they go together. Well, this has got one valence electron. Okay, so here we go. Well, oxygen's not happy, so we needed to bring in another silver to kind of bond and figure that out, so that when we were to rewrite it, we'd have Ag plus another Ag with a plus, and oxygen would have all 8 valence electrons around it, and it would have to have that 2 minus charge. You do not have to write that down, it's just kind of a recap. But if we take a look here, +1 plus a +1, that should be an overall positive charge of +2, and then right here, -2, so you can see that your positive charges equaled out your negative charges. Okay, that's the same thing we're going to do here, but we're going to do a little bit quicker. Instead of having to draw out all of those Lewis dot diagrams, we're going to use what's called the crisscross method. Okay, and I encourage you guys to actually physically do this when students struggle. They are too lazy to actually write this down. But why? I'm giving you the tool. Make sure you use it, okay? It's so simple. It takes all of 5 seconds, maybe 10 seconds if you got to, really find the right charge and the right substance on the periodic table. It's taking you a while, okay? All you're going to do is one extra small step and you'll have it right. We're going to write the ions with their charges. Again, charges are going to be key here. Cations are always first. Here's a kind of the question of the day. Why do you think cations are always first? Well, simple reason why is because they have the lower electronegativity. Okay. If you also look on your periodic table, so I'm going to go back a couple of pages really quick. Okay. Take a look where the cations are, guys. They're over here. They're on the left side. Anions over there on the right. We have a lot more cations. Oh, so we're going to be kind of the same way. They're going to be on the quote-unquote left side of the formula, which means they're coming first. So remember this. People will forget this at times. Probably in this practice worksheet you're going to work on here in this video. Cations always have to come first. Okay. Second thing, we're going to then, once we've written them out, we're going to cross over their charges using the absolute value. So drop the sign. We're only worried about the number. So what we've effectively done here, if we take a look, is, okay, when I draw my circle, I'm only going to draw it around the number. This is like saying a -1. They're going to crisscross. Physically draw this. This is what I mean by doing the crisscross method. Physically write out the ions, draw the arrows to show where they're going, and they become subscripts. Okay, so to balance out the positive charges, okay, how many atoms we need of this -1 is going to be, how many we need to balance this out. So we would need, if we wrote it out and actually drew out our Lewis dot diagrams. Okay, oh, this guy's going to go there. Well, bromine's happy with only one, so we're going to need a second one to kind of come along to balance that out. So all we're doing is taking the charge kind of much faster than drawing all that out and making new subscripts. Last thing is, we make sure that the subscripts are always in their lowest whole number ratio. What's that called? Lowest whole number ratio. That is your empirical formula. Okay, ionic compounds. Okay, ionic compounds only will be an empirical formula, meaning the lowest whole number ratio. So we're going to reduce those subscripts down if we can. Okay, so that's how we form them. How we name them is very simple. Okay, so it comes from the cation and the anion, and you just kind of smush them together. Okay, they're no longer ions though, so we don't need to write ion for, like in this example, it wouldn't be barium ion, it's just barium bromide. Okay, so first write the ions formed for the following elements, then we're going to use the crisscross method to determine the formula, then you're going to name the compounds. So I'm going to kind of walk you through the first one and what I want to see on this entire worksheet. Eventually, guys, you will not have to write the ions out first. You should be able to do the crisscross method in your head. But if you're stuck or you find that something is weird and you're like, I can't figure it out, go back and actually write it out. So here we go. We've got magnesium. It's got a 2+ charge. We've got iodine. It's got a 1- charge. So I'm going to do my crisscross method. Remember, I'm taking the absolute value. Charge has nothing to do with it because you can't have a negative number of atoms. You can only have positives. So my formula unit here, notice, oh, formula unit, what does that term mean? It means ionic, so it's called the formula unit. Mgi2 would be our formula unit. We're going to name this. Well, let's think. This is the magnesium ion. This is iodide. We're going to smush them together and drop the term ion. So this is going to be called magnesium iodide. And my tablet is being weird. Here we go. All right, so that's how we go through it. Now, I want to jump down to number 9 and do that with you. Then you guys can go ahead and work on the rest yourself. And then I'll go over and kind of show you the key here as well. So down here, what do you notice is different about number 9? What does this mean? What do we have there? It's a transition metal, right? So it tells you what charge you're going to use. So when we write our ion, this is copper 1+, and this is oxygen. Again, the anion, guys, you're always going to know the anion's formula, or excuse me, charge, okay? It's always known. Transition metals are the ones you're going to have to figure out. And we'll talk more about that in the next video when we talk about ternary compounds, trying to figure that out. Here they gave it to us, okay? They gave you the charge on that, so it makes it a little easier. So here we go. We're going to pause. I'm sorry, not pause. We're going to crisscross. So our formula here is going to be Cu2O. And then to name this, notice how I name it. It's copper. We have to include this. Okay, it's telling us the charge on that transition metal. So this is copper 1 oxide. Okay, so what I want you guys to do is I want you to go through, pause this video, and then I'm going to pause as well. I'm going to put in all the answers, and then I'll kind of talk through a couple of them, and you guys can check your work. So take the next 5 to 10 minutes or so, however long it takes you, go through, do everything that we just kind of walked through with these two, and see how you did.